Okay, so now we're about to go into identifying the base case. So we've already identified the solution or the problem that we need to solve, and we're learning how to break it down into little small pieces. So that's what recursion is about. So it's in your best interest to, learn it as much as you can, get an understanding of it. You're not going to completely understand it right now because it's still a lot of information that we're throwing at you. So again, take it one step at a time. Understand the process. It took me some time before I got my head around all of this because I didn't have a mentor. I didn't have anyone who can show me how to understand it and how to navigate through not LaunchCode, but through JavaScript. So I had a lot of anxiety. I had a lot of times where I was frustrated and, man, but you have us, you have IAs, and you have me to help you navigate through it, to help you understand those things that I wish I had known or someone could have told me early on when I was starting my journey learning JavaScript and Java. So if you're new to this channel and you would like to follow along with the curriculum, it is free. All you have to do is click the link in the description and you can follow along with us as well. So without further ado, let's finish up this section. Identifying the base case. For and while loops end when a particular condition evaluates to false. In the examples above, these conditions are I less than r dot length and r dot length greater than 0, respectively. With recursion, we do not know how many times combined entries must be called to make sure the code stops at the proper time. We need to identify a condition that ends the process. This is called the base case, and it represents the simplest possible task for our function. Notice simplest, okay? If the base case is true, the recursion ends and the task is complete. If the base case is false, the function calls itself again. And we've kind of touched on this when we were working with the validate input. Now we check the base case like this. Function, combine entries, we pass in the parameter, and if base case is true, it's going to run whatever code is here. If it's not, it's going to keep calling itself until it gets to true. So that's if else. If this is true, run this block of code. Else, if it's false, run this block of code. Now for the joining task, the base case occurs when we pass in one element array, which would be the L character string. With no other elements to join together, the function just needs to return L. Let's update combine entries to check if the array contains only one item. Here we go. Notice here, this represents the item. This represents the index. Remember, there may be 5 items, but the index stops at 4 because it's 0 base. Just remember that. So if this is true, then this code runs. If it's false, then this block of code runs. Array.length less than equal 1 sets up the condition for ending the recursion process. If it is true, the single entry gets returned and the function stops. Otherwise, combined entries get called again. We define our base case as array name.length less than equal to 1 rather than array name.length strictly equal 1, just in case an empty array gets passed to the function. So this is why I've been telling you that as a developer, you must know what the output or the result is going to be before you write the code. And also you got to cover different use cases. This is what we do. We go through and we cover for other use cases. Just in case this happens, we need to cover for that. And we'll call those exceptions, and we'll talk about that later. Now the case for the base. What if we accidentally type array.length strictly equal to as the condition for ending the recursion? If so, it evaluates the true for the array 0, 1, and the function returns 0. However, this leaves the element 1 in the array instead of adding it to the string. By mistyping the condition, we ended the recursion process too soon. Similarly, if we use an array with the bracket notation 0 strictly equal to rutabaga as the condition, then any array that does not contain the string rutabaga would never match the base case. In situations where the base case cannot be reached, the recursion process either throws an error or it continues without end, an infinite loop. Correctly identify and checking for the base case is critical, keyword critical, to building a working recursive process. So again, check your understanding. Remember now, you are the developer. It is your responsibility to make sure the code covers different scenarios. And that's what we're here to help you navigate through. Okay, so now we made it to the end of this complete section. Remember, the more you do, the more you improve. See you in the next section.